This is Software Engineering Radio, the podcast for professional developers, on the web at se-radio.net. SE Radio brings you relevant and detailed discussions of software engineering topics at least once a month. SE Radio is brought to you by IEEE Software Magazine, online at computer.org/software.
RethinkDB is an open-source database for the real-time web. Slava Akhmechet is the CEO of RethinkDB. Slava, what is RethinkDB?
Well, RethinkDB is an open-source distributed database designed from the ground up for the real-time web and real-time applications. And the idea is that, when we started the company, we noticed that the world is really moving towards real-time. People build much more collaborative experiences. For example, applications like Slack or Google Docs, where people collaborate online, and when someone makes a change to anything, it's really important for other participants to see it right away. And we noticed that the database architecture really wasn't written for this. So people make, developers, they make all kinds of really complicated decisions to build these apps. And we thought, hey, this could be dramatically easier. Let's build a product that makes building these kinds of apps much, much easier to do, because that's where the world is going. And that's how we started Rethink, and that's what it's for.
At a slightly lower level, what problems does RethinkDB solve?
At a lower level, the problem is, so imagine, let's talk about the example of Google Docs. You have a document that the one user is modifying, and you have another document that someone else is looking at. So what you have to do is, whenever a modification in browser A happens, you have to store it somewhere and then push it back to browser B. So there's been tremendous innovation on the front end with things like WebSockets and Socket.io and all kinds of client libraries to make that possible. But on the back end, it's still really hard, because when you're working with a database, you typically, you just the way you query data is you send a query, you get a response. If you want new data, you have to send another query and get another response. So on a very simple level, like if you were to write this application in a naive way, what you do is you'd start querying the database over and over again in a loop, let's say every few milliseconds. And of course, that turns out to be a really bad user experience because the latency is too high. You can't send a query every few milliseconds. People typically set it to seconds. And the second problem was this: if you have a lot of concurrent users and you start querying the database in a loop, you just bring down the database, right? So it's really hard to do this naively. And then we can talk a little bit about how people build these applications today. But on a lower level, what RethinkDB does is the developer can say, instead of just sending a query, they can say, okay, I'm subscribing to this information. For example, I'm subscribing to anything that happens in this document. And when someone writes to the database sends notifications to all the subscribers saying, hey, this particular piece of data you were interested in, it's different now, it's changed. And this is done via a push message. So if you're building your collaborative application, each client can just say, okay, I'm interested in this specific piece of data, or these multiple specific pieces of data. And then anytime any client does anything, any modification, we push a message, and you can get it, and anybody who's interested in it can get it. So what that does is it makes it dramatically. So first of all, it solves the problem of bogging down the database. So it's very scalable because the database knows at all times what happens, and it can efficiently push these messages. And it solves the problem of your infrastructure getting much more complicated, because you can't do it in a naive way typically. So the way people do it now is, it's pretty hard. You have to add a lot of different pieces. And we take all of that complexity out. So the code becomes much simpler. The infrastructure becomes much simpler. You don't have to add a lot of different moving pieces. And the way we do that is by pushing these messages about data updates. Does that make sense, Jeff?
Yes, the push notification, and we will get into that. But what differentiates Rethink from other databases on the market? What are the most specific points of differentiation?
So the biggest piece of differentiation is RethinkDB is completely designed around push architecture. So anything that happens in the database, we can push a message up to the user. And I brought up a specific example of, the user's interested in this piece of data. But it's not just data, it's done for computations too. So for example, you could say, I'm interested in the top 10 selling products in my store. And then anytime something happens, the database will recompute this. So it isn't just looking at a specific document in the database, it's looking at a computation. And at the core of RethinkDB, there is a computation engine that's designed for push notifications. And, whenever something changes, we recompute things efficiently, push the message. And what that does is it makes building real-time apps dramatically easier. It's the main piece of differentiation in RethinkDB. And, there's a lot of other things, like we cared a lot about both the developers and operations people. So the query language is extremely convenient. It's very nice. RethinkDB is much, much easier to scale than a lot of competing systems. It's really designed with ops people in mind. The guarantees that we offer are typically much more, they're much more significant than what you'd get with a lot of database systems. So there's actually a lot in the internals that differentiates in RethinkDB when it comes to small technical details. But on a high level, the push architecture is extremely important. I think it's one of the first databases in the world to do this.
We will get into the engineering that underlies that push architecture. But first, how did RethinkDB originate? What is the origin story?
The origin story, so my background, I grew up in New York City, and I was, I'm a software engineer. I was working on Wall Street in the financial industry, and I was responsible actually for building custom databases for some of the high-frequency trading use cases we had, and nothing off the shelf, would do. So I worked there for a while. I learned a lot, but I didn't really like the environment. I went to grad school. And in grad school, I was studying brain simulation on supercomputers. So I learned a lot about clustering. I learned a lot about distributed systems. And in the meantime, I met my co-founder, Michael, who was, he was mainly doing a lot of web development, web applications, human-computer interaction, stuff like that. And we started talking, and I told him about what I was doing. And he said, hey, this is a huge problem on the web, and you seem to know a lot about it. And we just started brainstorming ideas. We noticed that the way people build and deploy web applications is changing, and these changes are going to percolate through the whole development stack. So we decided to start a company. And this was back on the East Coast in New York. And we kind of packed our bags and moved to California and incorporated and, just never looked back.
RethinkDB supports a push model, as you mentioned, rather than the request handling model. Could you give a broader explanation of how that compares to application development of the past that's based on request response?
Yes, so I talked a little bit about how if you use request response, you have to continuously query the database, which is really hard because you end up bringing it down. It's hard to scale, and the latency turns out to be pretty bad. And if you think about it, if you squint your eyes for a bit, the reason why request response model used to work for databases on the web for so long is because HTTP was request response, right? So you send a request, the browser sends an HTTP request to the web server sends a request to the database, gets the response, sends the response. But now that we have WebSockets, and the web server often has to push data to the browser, the top of the stack is no longer request response. It's much more complicated, right? And what people try to do is they try to shoehorn this request response database model on top of a completely different model for building web applications. So that's why push is very important. And I mentioned a naive way of doing it, where you just query the database over and over again, and that clearly people learn very quickly that doesn't work. So then what they start doing later is they figure out, okay, this doesn't work, we have to optimize it. And there's a couple of ways of doing it, but generally when you start doing that, your code becomes much more complicated because you have to split your code. You have to write to the database and then push a message somewhere else. And then you have to have a piece of infrastructure for keeping track of all these messages. You have to have code to route these messages among your clients. And if you have multiple web servers, if you're scaling your web servers, then the web servers have to talk to each other. They have to filter out the messages so you don't saturate your network. You have to do all these things, and it's really, really hard. And, the experts in the space can definitely do it. It's clearly doable, but it's really hard. And Rethink makes it really, really easy because you just use your database directly, and it's designed to handle all of that complexity. So the software engineer kind of pushes it pushes the burden into RethinkDB, and they don't have to worry about that stuff. Does that make sense, Jeff?
Absolutely. So many applications build push in the application layer on top of a database. Why is it better to have that layer within the database itself?
There are a couple of reasons. So the first reason is the database itself has a lot of knowledge that the application doesn't have. So one canonical example of this is suppose you're trying to get top 10 players in your game in real time. You can build, and you want to push that leaderboard to the clients in real time, show it to people in real time. So you can do this in the application, but it's really, really hard because if you, for example, learn that your number 10 player drops out, it's very hard for you to know what the next player is because the application just doesn't have that data. So it would have to send the query to the database and get it, and it would have to know which user to get. So it's quite challenging to do in the application. It's actually doable. People have definitely done it before, but you have to deal with a lot of custom code. So for each interaction you want to implement, you have to write a lot of custom code to deal with it. You have to deal with routing, and you have to add a message bus, if you ever want to scale, and you have to write routing code above that message bus. So you have to do all these things, and a lot of it becomes custom work. And, in software engineering, we talk a lot about abstractions, and we talk about the fact that if the abstractions are right, then everything is easy and everything kind of flows. And if the abstractions are wrong, then everything becomes really, really complicated. And doing data manipulation in the application like that is kind of the wrong abstraction because the application just doesn't have that information. It's all custom code, and you could do this much, much more elegantly in the database that's both more efficient and results in a dramatically simpler application code.
What is the full stack architecture when the database is pushing rather than pulling?
Okay, so people do this in different ways. Usually, RethinkDB users, they tend to use Node.js. Sometimes they use Ruby or Python. Sometimes other languages like C# or the JVM stack. But generally, sometimes it's not always the browser. Sometimes it's the mobile phone. So it's kind of hard to generalize, but I'll try. So generally what happens is you have your web browser, you have your web client, and it's communicating with the web server via some kind of a socket protocol. So WebSockets, typically people use Socket.io. You could use different libraries. So on the front end, it's usually a framework like React or Angular. Then there's a WebSocket connection to the web server, and the web server is usually Node.js or Python or Ruby. And then that communicates with the database via the RethinkDB drivers. So that would be the stack, the real-time stack if you use RethinkDB. And if you didn't use RethinkDB, the stack would be much more complicated because you'd need a database, you'd need a message bus, you'd need a lot of custom code in the application to push messages on the message bus and to read from the message bus. And people often add a lot of other custom code to hook into the database to kind of get updates and do computations.
You've mentioned messaging a couple times now. Push is usually handled in a messaging layer that is responsible for durability and delivery guarantees and other features. Is Rethink really a database with a messaging layer bundled in?
Okay, so I think thinking about it as a database with a messaging layer bundled in is kind of a good first approximation. If you think about it that way, you'll probably be right quite a bit about what RethinkDB can do for people. But it's not really designed with a message bus in mind. So message buses are very different. They have different purposes. As you mentioned, Jeff, they guarantee delivery. They have a lot of different features. They have pub/sub features. Rethink does this a little bit differently. What we do is, instead of thinking about everything as messages, we think about it as changes in the data. So, for example, if you're building a web application and you want to re-render your DOM every 5 milliseconds and show new data every 5 milliseconds, because if you do it faster than that, the user doesn't care, right? It doesn't matter. They can't see changes faster than that. So what RethinkDB will do, it has a feature called Squash, which will squash updates. So if multiple relevant changes happen within a 5 millisecond period, then RethinkDB, instead of sending multiple messages to the clients that's saying, hey, stuff keeps changing, it will wait 5 milliseconds and then send a single message saying, here's the changes to the data. And if the changes intersect, then it will figure all of that out, and it will send you the latest relevant piece of information. So for web developers, you actually want that. And of course, all of that is configurable, and people can turn it off and change that. But it's much better to think of it as differences in data that we inform people about instead of messages, because the use cases are different. And there are some things RethinkDB can't do right now, like the traditional message buses will do. So if you need guaranteed delivery and you need to make sure every message that you push on a bus you see, like RethinkDB is not the best product for that. There's much, much better solutions. What we do is we just make sure you get the latest piece of data you're interested in. So it's not about messages, it's about differences in data. Does that make sense, Jeff?
Yes. Does Rethink support PubSub? Is there like a PubSub API somewhere?
So a couple of people have built a PubSub system on top of RethinkDB change feeds, and it's actually pretty easy. There's some code. If you go to rethinkdb.com/docs, I think we have an example of how to build a PubSub system. So it's very easy to build on top of feeds, but we don't ship that natively. It's not part of the product.
Real-time is a buzzword that gets used a lot. How does Rethink define a real-time application?
We define a real-time application as basically an application when multiple users generally collaborate and they need to see the changes made by one user. All the other users need to see it within a very short period of time, probably under whatever's possible in HTTP. Let's say under 20 milliseconds. Although there are some applications where the requirements are stricter and you have to get to 5 milliseconds or so.
When you have those more strict requirements, does the usage of Rethink change, or does Rethink tend to just provide that latency and the bottleneck is more on the application developer?
No, the usage doesn't change. It's pretty much the same. So for our change feeds, the users can say which timeline they expect, and you'd be surprised. Sometimes you want it to be a little bit higher, like if you're rendering DOM and there's a lot of stuff going on, like let's say you're updating market data, about stocks, and you have this pipe and it's changing very quickly. You don't want to re-render the DOM more than, let's say, every 20 milliseconds, because if you do that, the experience on the browser becomes bad. So all the user has to say is, I care about updates within this bound of time, and then we'll bundle them, we'll dedupe them, we'll do all the work and send that information to the user. And the use it's exactly the same.
You've mentioned the word change feed a couple times. What is the definition of a change feed?
A change feed is a query in RethinkDB, just like any other query, except you tell Rethink, like, hey, when you send me the response, don't stop. Keep sending me updates when something changes. So it's basically, one way to think about it is a cursor. It's like a cursor that never terminates. So you open this cursor, and then whenever there's updates to the result set, the user gets these updates.
What is the data model of RethinkDB?
RethinkDB is a document store. More specifically, it's a JSON store. So what you store in the database, it's usually JSON documents, and it's extended a little bit. So you could store, geospatial data, GeoJSON, binary data. We extend JSON to deal with time a little bit better. And of course, it's all backwards compatible, so you could get JSON out. So it's definitely a document model. And then you can build relationships on top of that and do joins, which is a huge deal. Rethink is one of the only, I think, NoSQL products that supports distributed join queries. So it's a document model, but you could also model relationships very effectively.
What about the transaction model? If I update the database and as a result, some pushes occur to my application, at what point is the transaction considered complete?
So the push model in RethinkDB is asynchronous with respect to the writes. So when you do a write, there's a lot of guarantees that have to happen in a distributed database, to make sure all the relevant nodes got the write and so on. Then the client gets the acknowledgement whenever the data is safely committed to disk. The push notification happens asynchronously, We send it to, to all the relevant clients that are interested in it. And what the clients can do is there's some provisions, and we're extending that quite a bit actually, to correlate the write that happened to the message that happened. So you can, for example, tell, okay, like, I've received this message that means I've received the messages relevant to all of the writes, like this one and before that. So we do a lot of that, but there is no transaction with respect to push and messages because this doesn't really work well on the web.
What about the consistency model?
So RethinkDB is immediately consistent. When you do a write, you get the response notification, you read it, you always get, you can always see the write that you made. And with respect to a single document, you get all of the consistency and durability guarantees that you would expect of a relational database. We're very, very serious about that stuff. We're very serious about people's data, and you pretty much get all the guarantees that you get in a relational database, but only as long as you're looking at a single document, not across documents.
Is RethinkDB distributed or monolithic?
You mean with respect to like the network?
In terms of how people tend to implement it, how people tend to use it.
Oh, it's definitely distributed. So people typically start with a single, they download RethinkDB typically on their laptop. So you can develop on one node, and then when you need to scale, people generally build out clusters and they move up to 3 nodes, then 5, and then they keep going up. So it's definitely distributed.
So once they distribute, what kind of cap trade-offs does RethinkDB make?
Okay, so RethinkDB is hugely biased towards consistency. If you have a cluster or even multiple data centers with a lot of machines, and then you have a split brain scenario, you can only write on one side of the split brain. That's guaranteed. You can read consistent data on one side of the split brain. On the other side, you could read outdated data, but not by default. So you have to pass a flag saying, I'm okay with outdated data. So whenever there is a partitioning scenario, we're very highly biased towards consistency than availability. And the reason we do that is because it makes building applications much simpler because the application developer doesn't have to deal with conflicts. It just results in a dramatically better developer experience environment. So we tell people who need availability in the face of partitioning, network partitioning, we tell them to use other products. And there's really good products for that. They're typically much harder to program against, but they solve that problem much better.
What are the invariants that RethinkDB provides?
Okay, so this is a little hard because Rethink is a big product, but I'd say the biggest invariant is if you write the data and you get the acknowledgement, you can be sure that the data is on disk and you're going to be able to get it later. If you make multiple changes to a document, those changes are atomic. So, they're in a single document, they're either both going to get written or neither of them are going to get written. If the power goes out, it's not going to corrupt your system. So it's all of the traditional kind of asset guarantees that you get in a regular database. These are invariants in RethinkDB, except in RethinkDB, it's only true with respect to a single document, whereas in a relational database, you could do it across multiple rows and get transactions across rows, which isn't possible in Rethink.
Is there a scenario where RethinkDB can see stale data?
Yes, so this is actually extremely rare, but there are situations where if you have a multi-node cluster and you have what we call cascading split brain scenarios, so it's not just one failure in the network, it's multiple kind of cascading failures, and some of the nodes fail while some other stuff happens. There is a possibility of stale data. So this is very rare and multiple things have to go wrong, but it's possible. And we actually have modes in Rethink to deal with that stuff. So the user can specify, okay, I'm okay with seeing stale data, but get high performance reads in these rare situations. Or I don't want to see stale data. I always want consistent views, but the reads are a little bit slower. So we let the user control all of that behavior and kind of trade off performance and consistency.
Could you talk more about how RethinkDB handles write durability?
Yeah, so I mentioned a couple of times that we care very deeply about people's data because it's obviously at the core of everything, and you get the same guarantees for write durability that you'd get in a traditional relational database. But on a lower level, what happens when a user does a write is, so let's say it's a distributed scenario and you have, three replicas, which means you've asked the database to maintain three copies of your data. So what happens when a client does a write is RethinkDB will send that write to three different nodes in the cluster, and it will wait for the majority of the nodes to acknowledge the write. When the majority of the nodes acknowledge that write, the RethinkDB sends acknowledgement to the client. So then, if anything fails, you have majority of the nodes contain new data, and we timestamp everything and stuff like that. So if one of the nodes fails and then restarts, it will contact all the relevant nodes, ask for the latest updates, and figure all of that stuff out. So that's how writes are handled in the distributed layer, and then on disk, we have a storage engine that deals with it pretty much in a similar way as any other traditional database would. There's a couple of differences, but I don't know if we have time to go into that. Does that make sense, Jeff?
Absolutely. Do you agree with you've mentioned a couple times that there are scenarios where you need a different store than Rethink. Do you agree with the premise of polyglot persistence, that applications generally need a variety of databases with varying sets of features and guarantees?
So I don't know how I feel about it ideologically, but empirically, we always see that in our user stacks.
That's exactly what the MemSQL CTO said.
Really, I didn't know that. I didn't listen to that podcast. But yeah, it shows up. It's not just Rethink, though. It's people use 3, 4, 5 different systems to do what they need. And sometimes in really big organizations, what we see is they have a single store, for example, HBase, where they store all their data. And then for custom use cases, they take slices of data from HBase that are relevant to that use case and put it in a completely different product. And in a big organization, they can have dozens and dozens of different products and hundreds of instances across teams. So yeah, I'd say I agree with polyglot persistence.
You're saying you agree with it empirically, though. So is there some bright future where developers only need one database product that does everything for them?
Oh man, ideologically, I think it's very, very hard because the use cases are really diverging for people. People are doing a lot of very, very different things. And it's just, this diversity hasn't been around here in the 90s. Like in the 90s, all of the things that we did were the same. And now there's just much more stuff that happens in a typical infrastructure. So I honestly, I look at a lot of products, like we're very proud of what we've done with Rethink, and we think it's amazing. It's an amazing product for the use cases that we've built it for. But I also look at a lot of other things people are doing, and they're very, very impressive. So for example, Elasticsearch is just phenomenal for what it does. And I don't see how they could do what we do, and I don't see how we could do what they do well in a single product. So I think the web and storage is probably going to move closer to the Unix philosophy, where it's not quite, do one thing and do it well, but it's do a small set of things that are relevant to each other and do that well.
So in the polyglot reality that we live in, how does Rethink DB operate alongside other databases? What role should it play in a polyglot architecture?
So RethinkDB integrates with a lot of other database systems really nicely, and in particular, change feeds make that really, really easy. And there's some libraries that have been written in the community to integrate RethinkDB with pretty much any database in existence. We tell people to use Rethink for this real-time use case. It's very often the authoritative source of data. I can tell you a little bit about what happens in the wild, in real deployment. So people will very often use Elasticsearch for some of the full-text search functionality. They'll use sometimes message buses to integrate with other applications that use relational systems. Relational systems are typically there for financial processing, where transactions across multiple documents are important. So that's generally how it tends to work out.
Interesting. RethinkDB is written entirely in C++. This might be kind of a naive question, but why did you choose C++?
We chose C++ because performance was very important. And there were a couple of, if you look at the options, I think there were a couple of options we could have picked, and probably on the top of the list was C and C++. So we chose C++ instead of C because it gave us greater flexibility to deal with kind of bigger architectures. And a lot of the early people that started RethinkDB knew C++, really well. So it was a natural choice. Right now, there's more options. There is Go. I hear Rust is developing pretty nicely, and I really like that language. So Go still has some garbage collection issues that are probably good enough for most applications, but not databases. And Rust doesn't have GC in the same way, but it a lot of that stuff is still being developed. So I think for low-level infrastructure software like this, where latency is really important and performance really important, there's been a lot of development, but C++ is still, to this day, probably the best language, and probably will stay that way for a while.
Do you have much insight into what the things that Go or Rust need to overcome in order to be resilient and flexible enough as languages to have databases written in them?
Yeah, so I love programming languages. I'm kind of a PL nerd. And if you look at RethinkDB query language, you'll see that it was designed by a lot of people who hopefully understand programming languages really well. So I think about that a lot. I think with Go, it's just fundamentally there is a garbage collector, and they keep doing updates, and it keeps getting better and better. But for database, garbage collectors are really bad because that means there are stalls, and you can get a variance in the latency, for queries, and that's really, really bad for a database product. So for Go, I don't think it will ever be a good systems language for the kinds of products like databases, just because the garbage collector is baked in. Like the moment you get a garbage collector, even if it's really, really good, and even that takes, decades, getting that to be a good language for system projects like databases is really hard. For Rust, I think Rust is a lot more promising because it's designed for more lower level use cases. It's just a new language. It's going to take some time to develop. People have to learn it. They have to learn best practices. And, it's easy to learn a language. It's much harder to learn all of the icebergs that you're going to hit in production when you're architecting your application. So, yeah, I think Rust is a lot more promising. It's just new.
So since you're saying that you don't need garbage collection, or you don't want garbage collection when you're writing a database, to application developers who are listening to this, who all of the work that they've done has been in garbage collection based languages, they probably understand that garbage collection is this hazard. It can slow you down. It does have problems, but how does what is the paradigm shift you need to make when you are writing an application that does not necessitate garbage collection like RethinkDB?
Okay, so the problem with garbage collection is wonderful, of course, and the problem with garbage collection is latency. So if the GC kicks in, it's going to stall your thread, hopefully only a single thread. And then when a query comes in, that stall is going to be visible in the latency that the user is going to see. So you can't do that, right? That's very, very important. It's very important in the database to have as little latency variance as possible. If you don't use garbage collection, for example, if you use C++, then you're really switching to a whole slew of other techniques. And so some of the best thing you can do is you can know really well the lifetime of all your objects. And if you can tell the lifetime of your objects, you could just do manual memory management, and you can deallocate memory when it makes sense. And it works really well, for example, with short queries, because if I do a short query, I know when it begins and I know when it ends, and I can just deallocate all the objects at the end of the query. So that's extremely fast. It's very efficient. It works really well. And you don't need garbage collection. You don't have to deal with latency issues. If you have longer queries, of course, things get more complicated because you might need to deallocate memory in the middle. And there's all kinds of ways of doing it. You could use shared pointers. You could, use scope pointers. And shared pointers are really cool, except you can't have, cycles, so you have to design your code in a certain way. So you're going down a rabbit hole if you're not using garbage collection. It's a whole other thing.
So speaking of rabbit holes we can go down, RethinkDB is written in C++, but drivers exist for Ruby and Python and JavaScript and other languages. Could you describe the functions of a database driver and how a database driver interacts with a C++ database application?
Yes, so the function of a RethinkDB driver, it's interesting because it was very important for us to give people a query language that doesn't feel like they don't have to manipulate strings, right? It should feel like an API, like a library. So when you're querying RethinkDB in Python, it feels like you're just writing Python code. If you're querying it in Ruby, it feels like you're writing Ruby code, and so on. So what the driver does is it's really a thin layer that integrates extremely well into the development environment that you're used to. So it feels like you're writing in the language that you're writing in. That's the function of a RethinkDB driver, to provide people with the best possible user experience to query the database. Now, the way the driver communicates with RethinkDB is we have a wire protocol, and it's public. It's on rethinkdb.com/docs. Anybody could write a driver that interacts with this wire protocol, and it will work with the server. The wire protocol it's for TCP, so it starts out as binary, but it's basically JSON. So you could, you just send JSON on the wire, the database interprets it and sends back a response. And it's very efficient, it's very fast, it's relatively easy to implement. So that's why actually there's been so many community developed drivers.
So we've dived down deep. I'd like to zoom out again. How does a developer get started with RethinkDB?
Well, the easiest way is to go to rethinkdb.com and kind of read a little bit about what it does for you. And if it makes sense, you can download it very easily. It's available on OS X right now via Brew or Package Manager, DMG. It's also available in pretty much all flavors of Linux. We're currently working on a Windows port that's going to be available pretty soon. But you could also do it in Docker. You could deploy it in the cloud. You could use Compose.io, which is one of our partners that will let you deploy Rethink in the cloud. And a lot of people actually use them just to get a RethinkDB server for development. So there's many ways to just install it. It's really simple. It only takes a few seconds. And then we have really good documentation, and we have a lot of tutorials on rethinkdb.com. And a lot of people in the community have built a lot of tutorials. So I'd get started that way. I'd go through our guide. It's quite simple. And then if you have a specific stack, like, for example, let's say you use Angular.js, there's some specific tutorials for how to get started with RethinkDB in Angular, for example. And, the same thing for other frameworks. Is
there a notable developer experience difference between a user on a Rails stack versus an Angular or a Spring stack?
Yeah, so... Well, see, we're kind of jumping a little bit because Angular is a front-end framework and Rails...
Sure, okay, Express.js stack or a mean stack.
Yeah, so generally the user experience is really nice in Node.js because Node.js is an asynchronous language, right? So it works much, much better with change feeds. If you use Ruby or Python, if you're just using RethinkDB without change feeds, it's pretty similar to using any other database, and it's really nice. If you start using change feeds in Ruby and Python and other languages like that don't have asynchronous behavior built in, you have to use some of the libraries like Twisted or Event Machine, or Async.io in Python. There's a lot of options. So yeah, there's a little bit of differences in each stack, but generally it's very, very similar. Like the drivers look almost exactly the same. So if you have a Python RethinkDB code, and you look at it, you can convert it to Ruby very trivially.
So Meteor is a JavaScript application framework for building real-time apps that leverages Node.js. And it seems to me that Meteor would have a lot of synergies with RethinkDB, but maybe I'm off base here. Is that accurate, or do you know much about Meteor?
Oh, that's totally accurate. So we actually know the team, and when we were designing change feeds, the first thing we did is we met with the Meteor team and we said, hey guys, what do you see in the wild? What are the important use cases for your users? So we kind of collaborated with them to design the feeds in RethinkDB when it comes to the API. And architecturally, all of that happened a lot earlier, but the API and the user-facing stuff was done in conjunction with the Meteor team. And some people have done an integration with RethinkDB and Meteor. There's still a little bit more work that needs to happen before it's production grade, but people can probably start building apps on top of it now. So yeah, I think what Meteor has done is all of that complexity, they've baked it into the Meteor framework and took it away from application developers. But because they're dealing with database systems, it's hard to scale. For example, Meteor doesn't work with like sharded databases right now. So yeah, it's very close. We work pretty closely with them, and they've been immensely helpful in providing information about what needs to happen, in the database layer to have a phenomenal user experience for the application developer.
Is Meteor a leading indicator for how application development is going to be done in the future?
I think there is a lot of innovation going on in application development, and people are trying. So the world has clearly changed. Like the kinds of apps we're building is totally different. And people are trying a lot of different ideas. So if you look at paradigms, Angular does it one way. Facebook's React does it a different way. Meteor does it a third way. I think it's very hard to tell which way it's going to go, but I think it's pretty clear to everyone that it's going to change. It's already changed.
What is ReQL?
ReQL is a RethinkDB query language, and it's a query language we designed with a couple of important design goals. So one is we wanted people to have a really, really good experience developing in their native language. So if you're writing Python, ReQL code looks just like Python code, for example. The second thing we wanted it to be very efficient. So when you write a ReQL query and you send it to the cluster, it all executes in the cluster. The cluster figures out where to send it, how to get the data, how to do all that stuff, and you just get a response. So ReQL is really, really wonderful to use. And again, if you go to rethinkdb.com/docs, you can learn a lot about how it works, why it works, and how easy it is to get started.
What does it mean to have chainable queries?
Chainable queries is for listeners who've used jQuery before. You're already used to this idea. The idea, or actually for listeners who've used Bash before on the command line,
currying, right? Just currying in programming languages. Currying.
Yeah, so this idea actually shows up in a lot of different cases, but generally in Rethink. So imagine you have your table that has a bunch of documents. Let's say you have a table users that stores the user data. Then what you can do is you can chain a command on top of that. So let's say you wanted to join it with an organization they work with. So you say table users.join, company. And then after that, let's say you wanted to pull out only the fields you wanted to. So you say .pluck, user company. And then, so you can keep doing this. You can keep adding commands, and then the data flows from left to right. So it's sort of like pipe in Bash or like dot in jQuery. And you can basically manipulate data in very, very sophisticated ways. But to a user, it feels extremely natural because you're just building up this query from left to right. And anytime you get more data or less data, if you narrow it, you figure out, okay, here's the next thing I'm going to do. So it's an extremely intuitive way to building very complicated data queries that you couldn't really do so intuitively in something like SQL, for example.
To emphasize this, could you explain what happens when I write a series of chained queries? Maybe you could give an example, and then you call run on the query chain. Explain in a little more detail what happens.
Yeah, so let's say I say table users.join, company.pluck username company name .run. So what I've done there is I took all the data from my users table, I've joined it with my company table. I only pulled out username and company name. And then I type .run and pass it a connection, which means, okay, it's time to run, to run the query. So what happens is the driver will take this whole query, the whole thing. So not just the first piece, then the second piece. It will take the whole thing, package it up in a JSON wire protocol, and send it to the cluster. So the whole thing gets executed in the database server. Nothing happens on the client. The database server will get the query, and the data could be on one node, or if you're sharded or replicated, it could be on multiple nodes. So the database will get this query. It will figure out where all of the data is. It will send the relevant messages inside the cluster, do the computations, get the data back, and then send it to the user. So from a user's point of view, you don't have to care if it's distributed or not. You just write your query. Everything gets executed on the server, on the cluster, and it can actually get really complex. Like you could do MapReduce, you could do aggregations, you could do computations, you could do a ton of different stuff, and all of that is handled by the database server.
RethinkDB is in production at hundreds of startups and consulting studios and Fortune 500 companies. Could you give an example about how a user from one of these companies is taking advantage of RethinkDB?
Yeah, so one example we give is Jive Software. So Jive Software, it's a public company. They've built a product called Jive Chime, and it's a messaging product for their users. It's similar to Slack or HipChat if people have used that before. But it's designed for Jive toolchain or Jive suite of products. So messaging is an example that comes up a lot. We have a lot of really interesting users in a lot of different verticals. One of my favorite ones is a company called Cmune that does gaming, in particular multiplayer gaming, and they use RethinkDB quite a bit. We're actually working right now on video case studies with a lot of our customers that we'll be publishing pretty soon. And what we do is we go out, we interview some of the folks there, and we ask them, hey, what do you like about the product? What do you not like it? How did it work out for you? What's the use case? So we'll be publishing video series pretty soon, and I'm very excited about it because there's some really cool use cases of RethinkDB that I can't wait to tell people about.
Can you give any previews on that? Like, what are the commonalities between what people say they really like about Rethink?
So the common things people say is they really like the push model because it makes their life dramatically easier when they build the application. They really like the flexibility of the query language, the fact that you could do joins and how easy it is to write. And they really like the fact that when you deploy RethinkDB and you need to scale it, the operational story is actually really, really good. So operations people love the product because they no longer have to wake up in the middle of the night to deal with problems. So these are generally three things people say. I can't talk about specifics though. I'd have to coordinate it with some people here. But yeah, I'm very excited, and we're going to publish a lot of that stuff really soon.
Could you talk any more about how you would make a messaging application using Rethink, or like what are the things that you don't have to do because you have Rethink? Or you could talk about games, or maybe the commonalities between those two verticals.
Yeah, so messaging, well, and even games. So in case of games, if you have a multiplayer game, and let's say you have a character in a specific location in the game and lots of other players around them, and then that character moves, let's say in a strategy game, you need everyone else to find that out. So you need to push that notification to all the other players. In messaging, whenever someone says something, you need to send a message to everyone who's interested. So for example, in Slack, there are channels, and if someone says something in the channel, anybody who's subscribed to the channel needs to see the message. So that's kind of the commonality, is the fact that you're pushing data. So if you were to do this the naive way, you'd have to query the database all the time to get the messages, and we talked about how that doesn't work. So what people start doing is they start adding pieces of infrastructure like PubSub, and then anytime someone sends a message, what they do is they split the code base. So the first part of the code says, okay, write this to the database because I might need this later. The second part of the code says push it on a message bus. And then there's a separate piece of code that has to maintain all of the channels and all of that information. You typically also store that in the database, and then whenever someone joins a channel, leaves a channel, you have to configure your message bus to account for all that stuff. So that's the kind of code you'd have to write. And then in the UI and the web servers, you'd have to write a lot of code to propagate that back, to the user. With Rethink, you don't need the message bus. You don't need to write any of that routing code. You just say, you don't have to split your code. So when someone, sends a message, you just write it to the database, and on the receiving end, you say, this logged in user cares about these channels. And then anytime someone writes to those channels, the part of the code that deals with that user is just going to get a message saying, hey, here's messages in all the channels this particular user cares about. So that becomes much, much simpler.
We talked about this some at the beginning, but I want to ask again after we've delved into the technical details, what is the key breakthrough? What are the breakthroughs of Rethink DB? What is being rethought?
So we started with kind of throwing out all of the assumptions about database systems and starting from scratch. And what we learned after a long time of doing this is that, and we kind of suspected a lot of this would happen, but so when you're dealing with disk and you're dealing with queries and you're dealing with all of the traditional like database storage stuff, the systems that were designed, 20, 30 years ago are absolutely rock solid. And you want a lot of that. You don't want to rethink any of that stuff. Like when you're storing data, we've solved those problems. Those solutions are really, really good. You don't want to be rethinking anything. It's just, those things are just really well done, and people have put a lot of effort into that, and a lot of thought, a lot of brain power, a lot of money, and those solutions are really good. When you're dealing with APIs, that is the part where you need to rethink a lot of things, because the way people build applications right now, in 2015, is just so different from the way we were doing it even 5 or 10 years ago. All of that stuff is different. The requirements are different. So rethinking that is really important. And another thing another piece of innovation that happened quite recently is the idea of distributed systems, because you can't fit data, on a single machine anymore. You can't meet performance requirements on a single machine anymore. So you have to rethink that part, and you have to, build a distributed system, which is really, really hard. So the parts that we've done that I'm really proud of is the distributed system in RethinkDB. I think it's excellent. It's really well designed. It's very safe. It's very, very easy to use. So I'm very happy for that. Requel, I think, is very well designed, very easy to use, very intuitive to write queries. And the idea of change feeds, the idea of building the whole architecture around push, I think I'm also really proud of, because it legitimately makes people's lives 100 times easier if they're building these kinds of apps. So these are the things we've done differently. And on the storage side, and just kind of traditional database stuff like asset guarantees and all of that, we try to stay as close to all the work that people have done, in the past probably half a century in the database world, because we think that part doesn't need to be rethought, and it's really, really well done already.
What is the business model behind Rethink DB, the company, and is there a close analog, maybe Red Hat or Cloudera, and how does this affect the developer?
Okay, so RethinkDB is open source, and we're open source, both functionally because the code is online, but also in spirit because all of the development happens on GitHub. So anybody could go on GitHub issues, comment on features as they're being designed, and we're collaborating really closely with our developer community. The user community is absolutely wonderful. It's very vibrant. We get a lot of feedback. So the whole thing is open source. As far as business model, we provide a lot of services to organizations. We provide training both on-site and online to help people bring their developers up with RethinkDB and bring them up to speed. We do developer support, so as people build applications, we can help them learn things and get to market faster. We do production support, so if something goes wrong, we help people out. Generally, we do support over Slack, so they get a real-time channel to our core development team, and we can use other message systems too. So people really love the support model. So that's what we're doing right now. We do health checks for people, when they deploy in production, things like that. And we also have a lot of plans for different services on top of RethinkDB that will make people's lives a lot easier. And I can't talk about that right now, but hopefully that's going to start coming out, next year. So there's a lot of really exciting stuff we're working on. But right now, it's been a lot of just basically doing services for people and helping out with getting apps developed, getting into production, and making sure everything stays great once the app is out.
So you've mentioned a couple resources that aren't quite ready for publication yet. Where can I put what in the show notes that if people click on these pointers in a few months or 3 months or 5 months, these resources will be available? Where should I point people to if they want to find out more about RethinkDB?
I would point people to rethinkdb.com. That's the biggest repository of information on RethinkDB. And it's pretty easy to read, it's well designed. There's a lot of info there. People should be able to get a lot of information. We're also on Twitter, so at RethinkDB on Twitter. We're very active there. We respond to most questions. So if users have a question, you can just ping us at RethinkDB on Twitter. We'll respond. My personal email address here is slava at rethinkdb.com. So feel free to send me an email if you have any questions. And I'll, it gets sometimes quite hard, but I'll try very hard to respond to every email. So yeah, I'd say use these resources. It's just kind of also GitHub. GitHub is another good one. So RethinkDB on GitHub is very active, and everyone's very responsive.
Are there any closing thoughts on RethinkDB or application development or computer science that you'd like to provide to my listeners?
Yeah, well, we're very excited about what's going on in the web because there's a lot of innovation. There's a lot of innovation happening in the browser, and this is really important because it's really changing the way people build web applications. There's been Angular and Meteor, and React is doing some quite amazing things. And as people build more and more sophisticated front-end applications, it becomes quite clear that the rest of the stack needs to change too because things get very complicated. So that's why we started RethinkDB, and we're very excited about a lot of the work that we're doing. So that's the first part I wanted to say. The second part is that I wanted to thank all of the open source community people that have been engaged with RethinkDB, that have been so helpful, going to hackathons and doing tutorials for people, going to meetups, giving feature suggestions, bug reports, helping with feature design. Thank you guys so much. The product couldn't have been nearly as good as it is now without your help.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more information about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can write comments on each episode on the website or write a review on iTunes. Mention or message us on Twitter at SE Radio, or search for the Software Engineering Radio Group on LinkedIn, Google+, or Facebook. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under the Creative Commons 2.5 license. Thanks again for your support.